Hi, and welcome back to the next lesson. Today we're going to be talking about stacked bar charts, and you'll notice there's a number of different options here, so we're going to have a little bit of fun going over this, and then what we're going to do is take an Excel lesson as well as we manipulate regular data and regular bar graphs and create some of these on our own. But first, let's get the background and the basics, and then we'll head to Excel in the next lesson. Now, if you remember earlier on in the course, we discussed the concept of composition versus comparison data. And now we've really come to the point where we're going to be talking about composition data. And that's best described in 100% stacked bar charts, as you see here. And you'll also note in a couple minutes that we have 100% stacked horizontal bar charts, which again, basically do the same thing, but we're going to look at both. A key point to note here, as you may or may not be aware of these types of graphs, is that on the y-axis, rather than the data point values itself, such as 75 or 40 or 100 million, what we have is basically a 0 to 100%. And then on the x-axis, we have our variables, again, using the standard A, B, C, D, E products. Now this type of graph is really best understood through a use case. So let's just walk through a typical use case scenario. You can see here in the legend that these two particular colors, which again, going back to color scheme real quick, you'll notice that they are related. They're not contrasting. So we know that there's a definite relationship between the two. So with that said, let's pretend that this relationship is regarding, let's say sales for product A through E. So with products A through E as our x-axis variable, we're going to split all the data into east versus west, obviously a geographical distinction, and we're going to identify with the y-axis 0 through 100% just exactly how the data points are composed when they're compared east versus west. So let's have a look. Let's take note of product A first. Notice how the first east legend here, starting from the bottom, it rises up to, let's just call it 45%. So basically that's telling us that at this most recent period in time, for whatever date this data is dated as, that east represents 45% of product A's sales for this particular company. In contrast, take a look at the second half of the bar up top. Doing the math, obviously, it's 55% that's associated with the West Coast. So from a geographic perspective, an executive or an operations manager, or even yourself, can take a look at this chart and see right away the breakdown in your data between East and West. And again, tying this back into the beginning of our lessons, it has to do with the granularity of the data. Let's pretend that the data behind this is actually individual household data. So we would have data regarding address, township, county, state, geography, country. And so what we've decided to do, because we're not reporting by street and we're not reporting by township or county, we're actually rolling up the data to a larger grouping or a larger perspective. In this case, geography. We're rolling it to east versus west, which realistically would be one step below just listing the general country. So with that little review out of the way, let's take a look at the next, product E. We can see here easily, East Coast is really about 25, maybe 23%, while the remaining is with the West. Same with product D, C, and then B at the end. Now, where this really becomes useful in terms of presentations is if you're trying to present opportunity. Say, for example, you're speaking with a group of executives or managers, you can highlight product B as very successful in the East Coast industry. But look at its West Coast exposure. It's minimal. Let's call it 15%. Whereas products D and E have close to 80% of their sales coming from the West Coast. And a typical use case in this scenario would be one, whether you want to increase East Coast sales in the remaining 4 product lines, or if you want to look what you're doing differently in product B versus the rest of the products to try to increase the exposure of the West Coast to product B. Now again, you have to remember, this isn't representing total revenue as a whole. This is representing portion. So ideally, if you were focusing on product B as your point of interest, when you increase West Coast sales relative to East Coast, you will still necessarily be increasing total sales as a whole. So there's no cannibalization, and it's not a trade-off between the two. But again, if we remove ourselves from the business perspective, let's go back to the data visualization point of it. If you briefly look over this chart as a whole, you can just easily see the layout between the 5 right here. You can see what products are strong where and what products are not strong. So let's move on to the next slide, because the next slide is an interesting adaptation of this as well. So you can see here, we're back now with East and West Coast, but instead on the x-axis, instead of products A through E, we actually have a time series. So that means that we're dealing with just one product here, or the entire group of products as a whole. Let's just pretend for this sake that it's company sales, company-wide, irregardless of products. So we're looking at company revenue of, company C, let's say, and West Coast versus East Coast geographical distinction. From a business perspective, we want to know where we're strong and where we're not. And this time series really is invaluable for that. If we follow each and every month from January 2011 through December 2013, we can see the ups and downs over time of when the West Coast versus East Coast was responsible for more revenue. And in this particular data series, you can see it's kind of up and down, but in a general business sense, it's not going to change this drastically over time. More likely, you're going to see a stabilization. So in reality, let's say the East Coast on average boasts 80% of revenue, whereas West Coast is responsible for about 20%. Now, if you present this to executives, they're going to take away from this the fact that they need more West Coast exposure. Again, because there's no cannibalization involved. Increasing West Coast exposure does not impact the East Coast sales. It simply moves the percentage of sales for the East Coast down to a more mixed level. So you can see from an executive point of view or an operational manager point of view, this sort of display is key for identifying sales compositions, cost compositions, profitability compositions, efficiency compositions as well. And in terms of presentations, my general rule of thumb is that you always want to place at least one of these 100% bar charts in any presentation, no matter what, because they're so powerful, you just don't want to have a presentation without them. And I really do follow that rule of thumb almost always. And a reason I like to follow that, I kind of coined the phrase in my own mind, is multidimensional insight. It tells you information. It tells you information about the product, about the time, and about the composition of that product. So now that we talked about 100% stacked bar, let's go back to stacked bar by itself and take a look. Take a look at what it is and take a look at best practices. It's similar to a 100% stacked bar, except in this case, the composition of the data points shown are actually based on the data values themselves rather than the data as a whole. So if you look at the chart here, let's just pretend that we're going back to the previous bar charts that were all gray. If we had that here, we would just see all these data points as one large gray. But instead, we see each data point split into two different colors, and that's where the composition comes in. So take a note at the y-axis. See how it's no longer 0 to 100%, but now it's simply 0 to the value up top, the data point value. In this case, 250 is our upper limit. And again, going back to color scheme, because it's very important in these presentations, is that you want to choose a matching color scheme because there's a true relationship involved here, and you want to display that to your audience. Because the data points have not changed, we can pretend this data series is based on revenue or profits. It's just a matter of granularity that we're displaying. And next up, we have the horizontal stacked bar. And then afterwards, we're going to go to the 100% horizontal stacked bar. But first, let's just stick with the regular horizontal stacked. Now, there's a couple things to know. It functions essentially like a regular horizontal bar, except that it again is a composition measure. So it's going to be broken down into a different level of granularity. And you can see in this particular example that granularity is product. It's product A, product B, and product C. Now, something useful I did here too, which you may have noted on a couple charts back as well, I actually added the data values in themselves. I noticed especially with the horizontal bar charts like this, the stacked bars, that because it's not a vertical over time that you can see as easily, I noticed that it helps the audience a lot in this particular case if you include the values as well, because it's not quite as intuitive if you go from top to bottom and try to discern patterns based on the color changes over time, like it is with the vertical. So I just do that as, my own personal rule of thumb. If the display allows it, I try to add the values in, and if it doesn't, I try to modify the display a little just to get it in there if I can. Like the regular stacked bar that we saw a couple minutes ago, the data series are related, and the color scheme reflects that. And this is a good choice for categorical variable. As you remember before, horizontal bars are typically displayed with categorical variables. So if you had a categorical variable such as company, you'll want to display it this way, preferably over the vertical horizontal stacked bar, which is more ideal for one data series, like say company A, over a period of time. But if you're just analyzing company A and its many different products, you'll want to stick with the horizontal stacked, or in this case, when you have 3 products and you're analyzing multiple companies. But with that said, we're going to get into a lot more detail with these once we hit Excel and start taking a look at these. But first, let's go to the horizontal 100% stacked bar. Now, I did this on purpose. I actually left out the data points themselves, the text, like I had in the other one, just because I wanted to show you the difference between the two. It's up to you whether you agree or not. It's really a matter of personal preference, that it's easier to read this when there's text in here. So for example, company G inside would say 19%, and then about 59%, and then the missing value in the middle. So some key things to know. First of all, these are less visually informing than the standard vertical stacked 100% bar. Quite honestly, they're a little hard to read, but they are useful for instances where there's many rows of data, such as company or product A through M. Note now what happened. The 0 to 100% is now on the x-axis, whereas our categorical variables are on the left y-axis. And you should note too that it's intuitively a little more difficult to analyze this. I do like these, but quite honestly, I rarely use them just for that reason. So with that said, that basically wraps up our discussion on bar charts and their many forms. The next lesson now is just going to go into Excel and create some of these. We're going to see the different options. We're going to explore what happens visually when you mix the colors with what they should and should not be. Same with axes and labeling. So let's go have a look.